Alright physicists, so we're starting motion and we're going to start with the simplest concept of all, speed. We're all used to measuring speed, but of course because it's science, we're going to complicate it just a little bit. We'll start off with two things. We're going to start off with scalar measurements and vector measurements. Scalar measurements are simple magnitudes. Magnitude is just a number, a size, so it's just a size, okay? An example of this is 9 kilometers an hour. We've all seen this in the car, 9 kilometers an hour. Now, a vector measurement, it has magnitude, so size, and direction. So 9 kilometers per hour northeast. And you see the difference, it has northeast. Alright, so let's very quickly go through the symbols and the units that we're going to use throughout this unit. Speed, the symbol is V, not S. That's used down here to be confusing. So speed, the symbol is V. So when we write out the equation, the unit is meters per second. Distance, the symbol is S. The unit is meter. So meter is our unit of distance. T for time, okay, and the unit is seconds. And that's it. That stays the same in both of the vector measurements and the scalar measurements. So let's go to our vector version of speed. We don't call it speed, we call it velocity. The unit is a V with a little half arrow over top. The symbol is meters per second with a direction. In this case we've written west, but meters per second direction. Displacement is what we call speed. It's the vector version of speed. It's a different thing. The unit is still meters, but it has a direction on the end. Now, the displacement is the distance and direction between start and finish, or point A and B. It might not be the whole trip, but you might go, what's the displacement between point A and B? And instead of worrying about the whole trip that you went on, you just measure from where you started to where you finish, or point A to point B. You don't worry about all the incidental stuff because you can't go in a straight line. Alright, let's show a simple example calculation. Alright, first off we have instantaneous speed. This is the speed that the policeman measures with his radar gun. Okay, so it is the speed at a single point in time. Now if we're being really honest, it's always going to be between 2 points, but point A and point B in time, but they're so small that it might as well be instant. Or we can deal with average speed, which is the speed between point A and B. And if you drive, say, between Bathurst and Lithgow, there's the average speed cameras, and they measure your speed from one point to another, and then they average it out. Alright, so we'll start off with average speed. That's what we'll focus on, just because it's a bit easier. So we've travelled 10 meters in this direction, 4 meters in that direction. Well, actually, we'll look at the formula first. This is our formula. So speed equals distance over time, and over here it's velocity equals displacement over time. And that's why it's kilometers per second, meters per second, meters per second, whatever direction. Now, back to this. So if we go 10 meters in this one plus 4 meters in that one, that's 14 meters overall. Time, it took 7 seconds for the whole trip. That's actually really fast. Well, so 7 seconds, and his speed is 2 meters per second. Okay. Now we go, this one's a bit simpler, 10 meters west, and they've done it in 3 seconds. So the velocity is the displacement over time, which is 10 meters west divided by 3 seconds, which gives us 3.3 repeater meters per second west. So that's how those calculations are done really simply. And then we'll include this one, to go through velocity just a little bit more. Alright, so here is our trip. We've gone 10 meters this way, but we couldn't go in a straight line. We had to go around some part of the playground. Okay, so we're around, and that's it. Now our velocity average, VAVE, is distance over time. So our average velocity is gone 35 meters in 50 seconds. T equals 50 seconds. And that is 0.7 meters per second. Okay, that's how fast we went. That's average speed. Now, the average velocity is we only went 10 meters north. We went this whole trip, but we went 10 meters north in 50 seconds. So our average velocity over the trip, which that should be AVE next to it, is 0.2 meters per second north. That's it. It's as simple as that. We're going to deal some calculations on that later on, and yeah, see you in class, physicist. Well done.